In this example, we will use our software package R to create a plot called the Scatterplot matrix. This allows us to look at the relationships, the individual relationships between our explanatory variables and the explanatory variable and the response. So in this example, Computer Manager needs to know how efficiency of her new computer program depends on the size of incoming data. The efficiency will be measured by the number of process requests per hour. The variable is the number of process requests, Y, and the explanatory variables are the size of data in gigabytes, that's X1, the number of tables used to arrange each data set, that's X2, and X3 is the operating system the program worked under, and that's either A or B, and we're going to denote that with an indicator variable where A is equal to 0 and B is equal to 1. So we want to construct and interpret what we call a scatterplot matrix for the data. This is a good way that we can see if there's relationships between our variables and look at the relationship between our individual explanatory variable and our response. So the first thing that we need to do is we need to run in each of the vectors of our data. If we have a data set coming from like an Excel file or something, then we don't need to do this part, but because we're running in the data as vectors, we need to combine these as a data frame and call them something. So I'm going to call it data. Data is equal to data frame. And then I just type in the variable name. So I'm going to start actually with the response variable. This is so all the top value of my scatter plot, or the top row, will all be the relationships between my explanatory variables and the response, where the response is on the vertical axis and the explanatory variables are on the horizontal axes. So I'm going to put in y, comma, x dot 1, comma, x dot 2, comma, x dot 3. If I run this line, I now have a data frame called data, and it looks up here and it says there's 11 observations for 4 different variables, and that's exactly what we have here. All right, so now all I need to do is I need to put in the command pairs data. And here is my scatterplot matrix. So I can zoom in on the plot and look at the relationship between each one of these variables. Now, X3 is an indicator variable, so it's definitely kind of a funny variable in a scatter plot because it's just 2 lines. It's just a 0 and a 1, but it doesn't really matter here. We can still see if there's an association between certain variables. So it looks like X1 and Y have a strong relationship, and X2 and Y sort of maybe have a relationship, and then it definitely looks like X3 and Y have a relationship. It sort of also looks like X1 and X2 might have a linear relationship, so that would be a problem of collinearity where our explanatory variables are related to each other. We might have a problem there. And then it looks sort of like maybe X3 and X1 are also related. So that's something that we need to kind of maybe consider when we fit the model. So again, the top row represents each one of the individual scatter plots of Y is on the vertical axes and X's are on the horizontal axes. And basically, these are just the individual scatter plots for each one of these relationships. The scatterplot matrix essentially just puts all of the scatter plots into one command versus having to do them all separately. You could do either, but this is quicker. All right, if we look at this half of the scatterplot matrix, then it's just basically the reciprocal of this side. So you don't need to look at this side if you've already checked out and interpreted this one. All right, hopefully that helped you understand how we can understand a scatterplot matrix and create it using our software RStudio.